Good morning, everybody. All right, so we have to continue working on this a little bit because we're having some trouble still. So we're going to focus today on slopes and equations of lines as well as parallel and perpendicular lines so that you guys make sure we get this down pat by the end of the week. So let's take our time, practice with this. So the first things first, the question says the points -4, -6, and -3, +2 are on a line. Is the point -2, 10 also on that line? Well, here's the work you got to do every time when solving this. I want you guys to use symbolic algebraic methods instead of plotting these points and graphing it because I want us to get used to the process. So that said, I'm going to first find the equation of this line right here. So I'm going to use these points. I'm going to call this x1, y1, x2, y2. I'm going to do -6 minus 2 all over -4 minus -3. Now, a lot of you are making the mistake, you're just putting the -3 here. Well, the equation itself calls for minus. That's why you input the -3. That's now a +3. I get a -8 over -1, which signifies to 8. That is your slope. I really need this skill mastered, like to a point, because it's just a basic formula. So now we know our equation. We know our slope, and that's y equals 8x plus b. Now, we got to find the equation of this line before I can even answer this question. I can use either one of these points. It doesn't make a difference what I use. I'll use the smaller numbers, smaller math, probably less error. So replace everything. This equals 8 times -3 plus b. 2 equals -24 plus b. Add 24 to both sides. So the equation of the line that has these 2 points is y equals 8x plus 26. Now we got some information to use to answer this question. So now you're going to go into use this point. Let's see if this point is on this line. So it's as basic as this. If I replace y with 10 and x with -2, and I get my left side equals my right side, well, turns out we got the right thing. So if 10 is the y, 8 times -2 plus 26, 10 equals -16 plus 26, and 10 equals 10. Yes, this point is on this line because we proved the true using math. That is as basic as it is. Back in 1 second. Okay, here we are. Our last example is just tying more of like the common theme of what we're doing with all this equations and stuff. First one's a parallel equation, second one's a perpendicular equation. Again, this is reviewed from last week just to hopefully we get on the right path this week and just nail it, knock it out the park. First question says, find a line parallel to y equals -½ x plus 8 that has the point -6, -5. All right. Well, we know the rule of parallel lines, they have to have the exact same slope, but a different y-intercept. So, from a very basic, we are going to replace x and y with their given points and solve for the y-intercept to answer this question correctly. So, let's go and do it. Y is -5, x is -6. So, -5 equals half. -½ times -6 is positive. 3 plus b. -3 minus 3. So, -8 equals b. Look at that. So, the line parallel to that line is simply -½ x minus 8. We use the math to prove it true. Okay? Remember, parallel, exact same slope, different y-intercept, and perpendicular lines, the slopes are reciprocal opposites. So, this one says, find a line perpendicular to y equals 2/3 x plus 8, and has the point 4, -2. Again, just follow the process. We know the rule of this slope. Reciprocal is 3/2. Opposite goes from positive to now negative. X plus b. Okay. Just like before, solve for the y-intercept. So let's replace x and y with the given values. So I got -2 equals -3 over 2 times 4 plus b. Now this should be mental math for you guys, but again, I'm going to show the thinking just so you see it. This is -3 times 4 is -12 over 2 plus b. This simplifies to -6 plus b. I'm going to add 6 to both sides and I get 4 equals b. So the perpendicular line to this is y equals -3 over 2x plus 4. Okay, remember, we could have the exact same y-intercept as this one. The y-intercept is not bound by any rules in perpendicular equations. I will see you all in class.